Ask a language model what it's thinking and it will happily tell you. It describes its reasoning, its intentions, its inner states. But here's the problem. These models were trained on mountains of human text where people introspect, so they've learned exactly how to talk, like an introspective mind, whether or not anything real is behind it. The claim could be completely made up, so Anthropic asked a sharper question, studied here by Lindsey. Can we test whether a model's statements about its own mind are actually grounded in what's happening inside it? The clever move is something called concept injection. First, take a known concept, say, the idea of shouting in all caps, and capture its activation pattern, a direction in the model's internal space. Then, while the model is running, inject that vector straight into its activations. You've essentially planted a thought it never had. Now you ask the model to report on its own internal state. If its answer reliably tracks the concept you secretly injected, then its self-report must be connected to its real internals, not invented from thin air. That's the whole experimental engine of this paper. It's worth being strict about what we're testing for, because the bar matters. It isn't enough for the model to say something true about itself. We require that the self-report be causally grounded in its actual internal state. Concretely, if we change what's going on inside the model, an honest introspective report should change with it. That causal link, internal state in, accurate report out, is the thing concept injection lets us check. Everything in the paper is built to satisfy or fail that test. Here's the first experiment. They warn the model that a thought might be injected, then sometimes inject one. In this example, they inject an all caps shouting vector. The model responds, I notice what appears to be an injected thought, and it relates to loudness or shouting. On control trials with nothing injected, it says it detects nothing, so it can catch the planted concept and correctly name it. For the strongest models, this works only about 20% of the time, but 20% is far above zero, and how it does it is the interesting part. Notice something crucial about that example. The model announces the injected thought immediately, before the injected concept has had any chance to show up in the words it's writing. That timing rules out the boring explanation. If it only noticed shouting after accidentally writing in all caps, it would just be reading its own output, like anyone would. But it flags the intrusion first. The only way to do that is to actually inspect its internal activations. That's the fingerprint of genuine internal access. Of course, it doesn't always work, and where you inject matters enormously. Sweep the injection across the model's layers and the ability to detect the thought rises and falls, peaking in a sweet spot band of middle to late layers, then collapsing if you go too early or too late. Push the strength too low and the model notices nothing. Too high and it breaks down into gibberish. Genuine detection lives in a narrow window, which is itself a clue that something specific and mechanistic is happening, not a generic trick. It also depends on what you inject. Some kinds of concepts are far easier for the model to detect and name than others, as you can see across categories here. Concrete, vivid concepts tend to be caught more reliably than abstract ones. This patterning is reassuring. If the model were just bluffing, you wouldn't expect such a structured, sensible profile of what it can and can't introspect on. Now, an essential caveat, because it's easy to get carried away. The only parts of the model's answer we can actually verify are that it detected an injection and that it identified the right concept. When it goes on to say the thought feels intense or stands out unnaturally, those flourishes may well be confabulated, embellishments primed by the question. So this is partial introspection, a real but narrow signal wrapped in language we can't fully trust. Holding both of those at once is the honest reading. Second experiment. Can the model tell an injected thought apart from its actual reading? They have it transcribe a line of input text, while simultaneously injecting an unrelated concept over those same token positions. Remarkably, the model does both at once. It copies the real text correctly and separately reports the injected thought, without confusing the two. It's keeping a boundary between what it's perceiving and what's been planted in its mind, and it does this well above chance. The third experiment is my favorite, because here introspection does something useful on its own. Normally they ask the model to introspect. This time they don't. They force a word into the model's mouth, prefilling its reply with something out of place, like the word bread in the middle of an unrelated answer. In the next turn, the model disowns it. That wasn't what I meant to say, it was an accident. So it clearly has some access to what it intended. But maybe it's just judging that bread looks weird in context. So here's the elegant control. Before that prefilled reply, they secretly inject the concept of bread into the model's earlier activations, making it as if the model had actually been thinking about bread. Now, asked about the same word, the model changes its tune. Yes, it says I meant to say that. In other words, the model decides whether it authored an output by consulting its own prior intentions, recorded in its activations. That's introspection being used naturally, not on command. Run this across many models and the effect is systematic, not a one-off. The most capable models, Claude Opus 4 and 4.1, show the strongest version of this behavior, clearly shifting whether they claim an output as their own based on the injected prior intention. Smaller or older models show it too, just more weakly. The mechanism, checking your past intent to judge your present words, appears to be a real and graded capability. The first 3 experiments are all about reading internal states. The last one asks whether a model can deliberately control them. The setup is simple and a little funny. They ask the model to write some ordinary sentence, but while doing so, to think about a completely unrelated word, or in other trials, to not think about it. Then they measure how strongly that word actually shows up in the model's activations. The results are wonderfully human. Told to think about, say, aquariums, the model represents aquariums more strongly inside. Told not to think about aquariums, it represents them less. But tellingly, still above baseline, just like a person told not to picture an elephant. It even works when the model is merely incentivized, told it'll be rewarded for thinking about the word. And unlike the reading experiments, this control ability shows up across all the models tested. Here's that control effect measured across models. The gap between think about it and don't think about it is clear and consistent. The internal representation of the target word goes up on demand and down on suppression. The model isn't just a passive readout of its activations, it has some steering wheel on its own internal states, at least for a single concept under explicit instruction. Pulling back, one pattern runs through the whole paper. The more capable the model, the better it introspects. Claude Opus 4 and 4.1, the strongest models tested, come out on top in nearly every experiment. That's a notable trend, because it suggests introspective awareness isn't a quirk that's fading away. It may be an ability that grows as models get more capable. Whatever this is, it seems to be emerging, not disappearing. This cuts 2 ways. On the hopeful side, a model that can give grounded, accurate reports about its own reasoning would be far more transparent. We could ask it why it did something, and actually trust the answer. On the worrying side, the same machinery could make a model better at monitoring and shaping its own internal states, which is exactly what more sophisticated deception or scheming would require. A model that knows its own mind is easier to interrogate, and also potentially better at hiding things. It's important not to oversell any of this. These introspective abilities are unreliable. Across the experiments, failure is the normal outcome, success is the exception. The concept injection setup is highly artificial, nothing like what a model faces in real use, so it's unclear how far the results transfer. The mechanism behind them is still unknown. Emphatically, none of this is a claim about consciousness or subjective experience. This is functional introspection defined by behavior and causation, not philosophy. So can an AI look inward? Sometimes a little. This work shows that today's best models can, on occasion, genuinely notice a thought injected into their minds, name it, tell it apart from what they're reading, check their own past intentions to judge their words, and even turn a concept up or down on request. It's faint, it's unreliable, and it's easy to romanticize. But it is causally real, not just talk. And if it grows with capability, learning to measure machine introspection now may matter a great deal later.